So you're back. What's the matter with you? No, you're doing the right thing. Stick with it. Let's have a go at the next question from the Yachtmaster Offshore syllabus on secondary ports. The next one we'll have a look at then is 10B, and that is Farlow River. Same process then, Farlow. Find out what page it is, page 61. And we have a look at Farlow, and it tells us the standard port is Namley Harbour, however you want to say it. Right, that here actually. That's our standard port. We're going to look for the time of high water. Oh, actually first we're going to have a quick look at Namley Harbour, because we want to check that it's a high water curve. It is. We knew it was a high water curve, but we always check because then we only need the time of high water to answer the question. Obviously you'd need the time of low water if you were planning on navigating in that area, and it's the 30th of August. Height of tide 1340 DST on the 30th of August. There we go, somebody's put a handy little box around there, which is a good thing to do, just so that you make sure you can quickly find that time again when you're glancing at it. Namley Harbour, 30th of August, height of tide 1340, so I reckon we want the high water there that's marked at 1602 in time zone UT, and we're going to leave it in UT. For the time being, because the adjustments tables for the secondary ports are only going to work in winter time. High water height 3.5 metres. Low water height, and it's the preceding low water, so that's 1 metre. Just glancing at that tells us which window to look at. So it's the window between 1602 and 9:30 in the morning there, which is going to give us that height of tide window between 3.5 and 1.0, giving us a range of 2.5 metres, which we'll have a look at in the standard port. It's very close to a neap range. So that's the dotted blue line as far as we're concerned. And then we want the adjustments for the secondary port on Farlow there. So let's have a look firstly at the adjustments in Farlow for high water. And we can see that if we had a high water at 12 o'clock, it would be -40. And if we had a high water at 1800, it would be -18. Now our time is somewhere between those two. Now I'm not going to take a shortcut like I did on the last video. I just want to, I'm not going to make you do something I wouldn't, so I'm going to measure out accurately. I want 6 of these, so if I use a 12-inch ruler here, and I can mark off my hours with 2-inch sections, so that's 1300, 1400, 1500, and so on. And the top line there is going to be the adjustments from the table, -40 to -18, -40 to -18. If we have a think about that interval there, that's 22 minutes. Now there's only one way you can split up 22 minutes, and that is 22 individual notches, or 11 notches that represent 2 each. We'll go with 11 because then I can use this 11-inch mark on the 12-inch rule just to give us those even intervals between them. And then that's going to be 38, sorry, these are going to have to be small. Minus 34, minus 32, minus 30, minus 28, minus 26, minus 24, minus 22, minus 20 and minus 18 on that end. And then as before, we're going to draw that one to there. The 1800 maps to minus 18 and the 12 maps to minus 40 there. Oh, look at this, we've got a parallel rule, so we can make it exactly parallel, which should take advantage of this method when we are looking to work out where 1602 is. That's just about there, like actually pretty much the exact, it's just a whisker past the 1600 mark there. So I'm going to just wonk it ever so slightly there. Look at that, looks like it comes out at exactly minus 25 minutes there for the adjustment. High water height then, similar process. We're going to look at the high water heights in the almanac there, and if we had a high water height of 3.4, then the adjustment would be plus 0.3. It may be tempting to think that actually we're close enough, but we will just double check by drawing another one of these crocodiles. So I've got 3.4 and I've got 4. So let's do 6 inches across there. 3.5, 3.6. You get the idea with this. Just showing you that it doesn't take forever to actually draw them accurately with a ruler as well. And then on the top line we've got plus 3 and plus 0.7. So we're looking at 4 of those. Let's do those with 2 inches each. Plus 0.4, plus 0.5, plus 0.6 and plus 0.7 there. Let's pop that one across from there to there. And we'll use that parallel rule, I like these things, to measure where our 3.5 is and see if we could have got away without even bothering. Oh, okay, I have to walk this this bad boy along. Oh, I don't usually do this. Whoa, you can see. Anyway, crikey, that's not easy on one of these slippery surfaces, but you could get the idea. That is quite a bit closer to the 0.4 there. So good job we did the crocodile really, otherwise we'd have been 10 centimetres out. All of these inaccuracies could start adding up, and if that was 10 centimetres of solid rock, we'd be sorry. Let's have a look at low water. Low waters are between 0.4 and 1.1. Again, might be tempted to think, well, that's near enough, plus 0.7, but we will draw it out just to check. And 0.4 to 1.1 there, I'm going to go left to right. That's my kind of method of doing it, just works for me, just a bit more logical. We're looking at 0.4 to 1.7, that's 7 along there, running out of room somewhat, so I'm going to just do little ones along here. 0.4, 0.5, 0.6, 0.7, 0.8, 0.91 and 1.1 there. Sorry, it's all a bit crammed in. It'll still work. And plus 0.2 and plus 0.7 on the top there. So there's 5 of those. 5 inches for the win. Plus 0.3, plus 0.4, plus 0.5, plus 0.6, plus 0.7. Really, this one's tiny, but it's enough for us to see our 1 metre is going to map to closer to 0.6. Plus 0.6 will be the adjustment for the low water height in our secondary port. So then all we got to do is the sums. 1602 minus 25, I make that 1537. Super quick with the maths. And 3.9 here, 1.6 here. And that's what that DST box is for here, because we're going to add it now, 1637 DST. So that's the data that we need to put into our standard port curve for Port Fraser. Did I say Port Fraser? Namley Harbour. Namley Harbour. That's the one. Got it written there, right there. Namley Harbour. Never mind Port Fraser. That was the question before. So there it is, Namley Harbour, and we've adjusted our data for the secondary port of the Farlow River. I'm going to pop that in. High water of 1637 is going here. I'm going to put DST under there because that's going to help reduce errors in the long run. 3.9 here. Just reduces confusion when we're looking at it. 3.9 meters there, 1.6 meters there. You can mark that on the sides here. You don't have to. Then you draw the scalar line between the two. And then we're more or less in a position where we can start answering the question that we were asked, which is at 1340. We're going to go on up to that neap curve there. And then we're going to go across to our scalar line. I'm going to do that as accurately as we can. So just past that, we'll draw a straight line to where it meets that curve, across there to where it meets the line, and we can read that up or down, and we can see our height of tide is 2.9 meters. In the Farlow River at 1340 DST. So, what clearance is there going to be under the rail bridge at this time? All right, so we'll have to have a look at Farlow River for the railway bridge. You can see from the chart that there's two bridges there, and having a read in here will tell us which one is which. The road bridge is 14 meters clearance and the rail bridge is 4 meter clearance. So that railway bridge is a 4 meter clearance. Here's the railway bridge. We draw like that. There's our railway bridge. There you go, how'd you like that? And that's 4 meters from highest astronomical tide. So there's always going to be a bit more clearance than that, because it's unlikely that we'd be going under there when our height of tide was exactly at highest astronomical tide. We're always going to be a little bit under highest astronomical tide, pretty much always. Where do we find out highest astronomical tide? Well, a variety of places. The training charts have got highest astronomical tide listed for quite a few of these ports, but not actually Farlow River. A tidal app for IMRE tides, something like that, would show you a HAT for major ports in the real world. And in the training almanac on page 12, we've got lots of data: HAT, mean high water springs, mean high water neaps, and so on. And for the Farlow River, highest astronomical tide is 5.4 meters. So if we were at 5.4 meters, we would have a 4 meter clearance. Now we are at 2.9 meters. So that is, if you imagine 2.9 is over here. This is us bobbing around on the 2.9 meters there. So we're going to have an extra clearance there, and the extra clearance is how much we are below highest astronomical tide. So that is to say 2.5 meters. So we can add that 2.5 meters to that clearance, and the clearance then is going to be 6.5 meters at 1340. And then obviously we'd have to think about, you know, what our air draft was on the particular vessel. But that's just the clearance, that's the absolute clearance. And then for a particular boat, we would remove our air draft from that and give us the clearance for that particular boat. But all we're asked is what's the actual clearance under the bridge at that time. So we've answered that. And then part B is what depth of water is there off the Upper Town Quay? Well, that one's dead easy by comparison. We just have to look at the depth at the Upper Town Quay, back to the chartlet for Farlow River there, and you can see the Upper Town Quay there has a charted depth of 1.2. Chart datum 1.2 metres. Our height of tide is 2.9 metres. So we're just going to add those together, and that's going to give us 4.1 metres depth at the Upper Town Quay. If we were to arrive at 1340 on the 30th of August. So that's answered question 10B. Piece of cake, yeah?